So let's try that again. When the H value is negative, it moves left. When the H value is positive, it moves right. So in the case, the summary is that a number inside the absolute value bars of the vertex is the movement left or right and is represented by H. A number outside is up or down. So in this case, it's down 2. Over here, we are up 6. And then when a number is outside the absolute value bars, the vertex shifts up or down. And that is our K value. A number in front is going to change the stretch or compress. So a 3 will stretch it or make it narrow. A 1/2 will compress it. And then we have our summary, which says that when a number x is multiplied, an absolute value function will be stretched or compressed. That's our A. If it's negative, then we say that it is reflected. So if there's a negative sign outside the absolute value, the function will flip or open down. Okay, on the back, you are simply matching these to their numbers down below. So number 1, your vertex was 1, 2, 3, 4 units to the left. So it was -4 and about 4 units up. So you were looking for a graph that had a -2, a negative to start. So you automatically had to eliminate C, E, and D. And then the +4. So you had -3, absolute value, x + 2 + 4, or A. In this example, it is at -1. It is shifted down. Probably about 2. It looks like the slope is about up 1/2. So open up, so that left C, E, and D. In this case, okay, we are looking at a graph shifted left, so that gives me example E. Three and 4 are definitely compressed. 4 is just shifted straight down. So we're looking for one that's just an absolute value without any changes inside. So compressed, no changes inside. And then you need to compare your shifts. So this is shifted up, this is shifted down. Therefore 3 is D. 4 is reflected. and compressed. So reflected and compressed only leaves example F. 5 has no shifts, it's just reflected, so it is the reflection of the parent function, letter B. And 6 is compressed and shifted up, so letter C. For the next part, we're going to check the next page in your packet. So here you'll notice we have an absolute value shifted down 2. Here we have an absolute value shifted up 3. Absolute value shifted down 5. So all of these have K transformations. K transformations will affect my range. All of these have K transformations. They will affect my range. In example number 4, we once again have a K transformation that is going to affect my range. So this is going to be down 4. No stretch or compress, so my slope is up 1, right 1, up 1, right 1. Five, your vertex is 3, 1, so it's 3 to the right and up 1. In 6, my vertex is -1, -4. So that will be to the left 1 and down 4. Once again, no stretch or compress. So we go up 1, right 1, up 1, left 1. And there's my graph. Okay. Then in 7, 8, and 9, these transformations are all affecting the A value. That means that they are going to be stretched or compressed. So go ahead and take a minute and investigate those 3 examples. Okay, in 10 and 11, I ask you to describe their transformations, identify the vertex, axis of symmetry, etc. That's going to be very similar to tomorrow's quiz. The only other thing you really need to know for tomorrow is what is the domain. So recall that the domain of all absolute values is all reals. And then what is my range? The range is always going to be y. It's either greater than or equal to with respect to reflected or not reflected. So this graph opens up. Therefore, it's y greater than or equal to the k value, which in this case is 4. In number 11, you have several more transformations. It's down, reflected, and stretched. So my domain is all reals, but now my range is transformed. It's still y, but it has to do with the k value, so it's -2. The reflected changes it from greater than to less than. And once again, it's always equal to. Okay, in the next example, it says to graph, list the vertex, x-intercept, and y. So our vertex is h comma k, so 4 comma 5. It is reflected. So let's start by graphing our vertex point. And then we are going to apply our -1 slope. So then what I want you to notice is this graph actually has 2 x-intercepts. We have one at -1, 0, and another one at 9, 0. The y-intercept is at 0, 1. So again, I waited to find the x and y-intercepts because I could see them once I graphed. So x-intercepts at the x-axis, y-intercepts at the y-axis. And then we just have those last couple examples down at the bottom. There won't be one like 19 or 20 on your quiz, so you can kind of, even if you want right now, ignore them. Let's focus on, actually you won't have one like 15 either, so, okay, your 15 is different than this one. I fixed yours. And your 19. So again, your equation for 15 is actually valid. And let's do this. We'll go back to paper. your vertex is 3, 0. That means that this is shifted right 3. For your quiz, I only need 5 points for each graph. The vertex, 2 to the right and 2 to the left. In 14, your vertex is negative 1, 3. The graph is reflected, left 1, up 3. And just to focus a little bit, the range would be y less than or equal to 3. Over here, my range is y greater than or equal to 0. 15, my vertex is negative 1, negative 3. This graph is left 1, down 3. Your range would be y greater than or equal to negative 3. And the domain is always all reals. In 16, it's reflected and up 2. In 17, my vertex is 3, negative 2. A 1/3 tells me compressed. It is right 3 and down 2. So remember the compressed by 1/3, that 1/3 actually represents my slope as well. So we're going to start at 3, negative 2. And then we're going to go up 1 and over 3. And hopefully you can see how this graph is much more wide. Okay, in 18, my vertex is 2, 6. It's reflected, stretched, right 2, and up 6. Every pretty much possible type of transformation occurring. So you have 2, 1, 2, 3, 4, 5, 6. Now it's stretched by 2. So again, here's my slope. You always apply your slope to the right. So it's down 2, right 1, down 2, right 1. Continued. And then we also know that whatever goes to the right, it goes equally and opposite to the left. And there's your graph. So to kind of conclude class today, I'm going to open up a Kahoot that is self-paced for you. It is going to give the top player from each class period bonus points. So what I'm going to do is put up that Kahoot pin for you now. And that's how you'll conclude class and study for tomorrow's quiz. Are there any questions on any of those handouts we kind of just went over? Anything you don't understand, whether you're at home or in class, again, you can ask away. Just to kind of talk about tomorrow then, If you are fully remote, you will take your class on Monday during class time. If you are in group A, your test will be Monday. If you're in person, group B, your test is obviously tomorrow then. So group A kids, I'm leaving the Kahoot open all the way till Monday. That way you can go through and kind of work at it maybe closer to the test time. So I'm going to share the URL in Teams and then you'll be able to work on that. If you're in person right now and you want to work on it, then the game code's right here. So again, if you're in group B, you should be taking this today. You need to have it taken before your quiz tomorrow. If you're in group A, you have to take it before your quiz Monday.